So in this video, we're going to talk about a few of the details involved in exponent properties. And the first one I'd like to look at is the case where we have a negative number raised to or negative and then a number raised to a power versus a quantity, a negative number, the quantity raised to the power. So when the negative sign's out in front of the 3 to the second power here without parentheses, this really means negative 3 times 3. Or another way to look at this is 3 to the second power, which is 9, and then take the opposite of that. So this answer is going to be negative 9. But when we have the quantity negative 3 raised to the second power, that really means negative 3 times negative 3, and negative times negative, as we know, is positive. 3 times 3 is 9. So you can see this notation would give us a negative value, while this notation would give it a positive value. Be careful what you're typing in your calculator to see what you get. Similar example there, 3x to the second means that only the x is raised to the second power. So this would really mean 3 times x times x. While the quantity 3x squared actually means 3 times x and then 3 times x again, because raising to the second power means multiplying a number by itself. But this number would be 3 times 3, which is 9, x times x squared. So 3x squared versus 9x squared. In our next example, x to the negative fourth is only it's only a power of the x. So this problem really means 2 times 1 over x to the fourth, which could be written as 2 over x to the fourth. That's different than the quantity 2x raised to the negative fourth, because the quantity 2x to the negative fourth would be 1 over 2x, the quantity still, raised to the positive fourth power. But then when we have a product raised to a power, we know that we can put the 4 into each part of that. So this would be 1 over 2 to the fourth times x to the fourth in the denominator here, which should give us 1 over 2 times 2, which is 4, times 2 is 8, times 2 is 16, x to the fourth. So you can see that there's a big difference of where the parentheses lie, or if there are no parentheses. Lastly, I'd like to show you negative 1 raised to powers. Negative 1 raised to the fourth power would be negative 1 times negative 1 times negative 1 times negative 1. The first two negatives come together to make positive. Then when that positive is multiplied by the next negative, that answer is negative. And when that negative is multiplied by the last negative, the result is positive. So negative 1 to the fourth power is positive 1. But negative 1 to the fifth power, well, negative 1 times negative 1 times negative 1 to the fourth power we just saw came out to positive 1. So if we just multiply that by negative 1 again, that's negative 1 to the fifth power, which turns out to negative 1. What we're trying to see here, or show here, is that really negative 1 to any even power will equal positive 1, while a negative 1 raised to any odd power will equal negative 1. Well, that's not cool. There we go.